So that's the definition to define inverse of a matrix. If A is a square matrix of order M and there exists another square matrix B of same order such that whenever you take the product of AB or product of BA, the resultant matrix is going to be I. Then the matrix B, what we have written, that matrix will be called as inverse of A. So denoted by B is equal to A inverse. That means instead of B, I can write it as A inverse. So this condition can be rewritten as A multiplied by A inverse is equal to A inverse multiplied by A will be equal to I. So that's a condition which you have to remember. That's a definition what you have to remember. Okay, students. On this we have two theorems actually. The first theorem proof is not required. Still it's given there, so you can just go and check. Okay. So what they said is inverse of a square matrix is unique. Unique means for one square matrix only one inverse. That is the meaning. So let's not worry about that thing. But the next one, few times they have asked in the examination. So what has been asked here is, if A and B are invertible matrices, show that AB the whole inverse equal to B inverse multiplied by A inverse. Just like we have in transpose, AB the whole transpose equal to B transpose multiplied by A transpose. Similar to that. Okay, so AB the whole inverse can be written as B inverse multiplied by A inverse. So we have to prove this. So proof, you need it. So I just wanted to remember this. Okay, right. So what does this says actually? AB is a matrix. Given A and B are two different matrices. When I multiply AB, I am going to get one more matrix. Let me assume the inverse of this exists. Then AB multiplied by AB, the whole inverse should be equal to I. This is the thing from where I am going to start the proof. So for A, see, it's been given actually A and B are already invertible matrices, because and that means their inverse already exists, right? So let me start with this. AB is a matrix multiplied by its inverse should gives me I. That's fine. Okay. So finally what we have to prove, AB the whole inverse equal to, AB the whole inverse equal to B inverse multiplied by A inverse. Correct. Right. Now multiply by A inverse on both sides. We'll multiply A inverse on both sides. So A inverse multiplied by AB multiplied by AB the whole inverse is equal to A inverse multiplied by I. A simple proof is there, so you can observe. And remember, matrix multiplication is associative. We know this. So instead of writing in this way, A inverse multiplied by A multiplied by B, because matrix multiplication is associative, let me retain this AB the whole inverse equal to, and a matrix multiplied by identity is nothing but the matrix itself. So I applied two things here. One is matrix multiplication is associative, other one is A inverse multiplied by I is nothing but A inverse, right? Okay, and A is already invertible. Now that means A inverse into A is nothing but I, because I already given a definition. A inverse into A is equal to A multiplied by A inverse, both are equal to I. So A inverse into A can be written as I multiplied by B, the whole inverse is nothing but A inverse. Correct? Now then the next, identity matrix multiplied by B is nothing but B itself multiplied by AB, the whole inverse equal to A inverse. So just multiply A inverse on both sides. These are the operations which you can perform. Now multiply B inverse on both sides. Multiply B inverse on both sides. So the right side, B inverse multiplied by B multiplied by AB the whole inverse multiplied by B inverse multiplied by A inverse. And look at the left hand side. B inverse is B. B is also invertible, therefore B inverse multiplied by B equal to B multiplied by B inverse is equal to I. That means B inverse B can be replaced by I. So what I got here, I multiplied by AB the whole inverse equal to B inverse multiplied by A inverse. It's a matrix multiplied to I, so you get back the same matrix. So AB the whole inverse can be written as B inverse multiplied by A inverse. A simple proof. Few times they have asked in the final examination, so I thought it's better to explain it. Okay, students, first one, don't give much importance, but remember for the sake of MCQs. So for one square matrix only one inverse will exist. That is what the statement meaning. Right? Okay. Now the most important thing, the expected one for 3 marks in the final examination. The next topic will be asked for 3 marks almost all the times. Almost all the time. 99% of the examination till date Every time they will ask you one problem from the next topic. The topic is find the inverse of the matrix, finding the inverse of the matrix by elementary transformation. Find the inverse of the matrix by using a concept called as elementary transformation. Students, nothing to worry about the elementary transformation. There is no procedure which you have to remember. Okay, you have to just follow my steps for 1 or 2 problems to understand the concept of what is the meaning of elementary transformation is all about. So if I say theory, you will not going to understand anything. So better if I start with an example, you will understand much better. Clear? So to do this, I will tell you how to start and how to end for each column. So procedure is this. They will give you a matrix A. Okay, you have to find out its inverse. What to do? First step number 1. Let us start with, let A is equal to I multiplied by A. This you have to start, right? This is the beginning actually. Some procedure will go on here. What should be the end? The end is this matrix A should be finally converted to an identity matrix. And the identity matrix on the right side should be converted to some matrix. It should not be identity. Okay, it's something like A, B, C. Some matrix you have to convert, right? And this A should be written as it is till the last step. This is the procedure. So I'm telling you once again. Beginning, let A is equal to I into A, right? So this is the beginning. So I'll tell you what to do. What is the meaning of elementary transformation is exactly, right? But just understand the beginning and ending. How to start and how to end it, and when to end it. That's most important for us. Clear? So let A is equal to I into A. After doing some operations, something like something and all, finally this matrix A should be reduced to identity matrix. This I matrix should be reduced to some other matrix multiplied by A. Don't substitute for this A till the last step. What is the meaning? See, a matrix multiplied by one more matrix is giving us identity matrix. Then the matrix what we obtained here, this will becomes A inverse, because we know that the property A multiplied by A inverse is equal to A inverse multiplied by A is equal to I. So what I am trying to do is just this one. But there is one condition. If the operations are started in row wise, continue in row wise only. Never interchange. First thing. Second thing, if you are starting the operations in column wise, continue in column wise. Never interchange the two methods. Clear? So this is how it should go. It should be done. So I am giving you a glimpse or a hint how to start, how to end the procedure. Okay. Now the exact meaning or the exact procedure. Okay. How to find inverse by using elementary transformation. I told you 99% most of the examination they will ask you one problem or how many are totally are there. See, in worked example there are 2. Okay. And the next one we have exercise problems. In the exercise problems there are 14. So totally some 16 problems. At least I will do 10 problems in this. Okay. So because I want to make sure we learn it. Right. Okay. So let me start from the exercise problems itself. What examples you can manage? Those 2 you can manage. So I'm going to leave those 2 for you. So the first one. A is equal to 1 minus 1, 2, 3. This is the matrix. I have to find its inverse by using elementary transformation. I told you the procedure, how to start. Let's consider A is equal to I multiplied by A. That should be the first step always. What does matrix say? 1 minus 1, 2, 3 is equal to 1, 0, 0, 1. Don't substitute for A. If you substitute also, it's not going to bother anything. But till the last step, you write down A as it is. Never substitute for this A. Clear? Right. I told you the beginning. Correct now? What is the end actually? The end should be this matrix should be converted to identity matrix, and this matrix should be converted to some other matrix and A as it is. Look at this. If I want to convert this matrix as an identity matrix, let us see. My first element is 1 and I required is also 1. That is what the first condition you have to check. If this element is not 1, you make it 1. Hope it's fine? Okay. It's already 1, so I got my first thing. Then, look here. This is 2. But what I want? 0. That means this element should be made as 0. To make it 0, see, this is an element of R1. See, the thing is, I'm starting row wise operation. So till the last step I should continue row wise operations. Okay, now this is an element of R2 and I want to make this element as 0, and look what I'm going to do. R2 elements will be written as R2 element minus 2 times R1 element. This is R2 and this is R1. Correct now. So here we have an element 1. 1 multiplied by 2, 2. 2 minus 2, it's going to be 0. Fine. So this is how the operation will be done. Remember students, my first row is unaltered. So I will have the same row, 1 minus 1. Write down first. Then come to this one now. So here, if I want, I will just write down R2 element. See, R2 element is 2. This I have written. Minus 2 times. Just above this, that's an R1 element. R1 element is 1. So 2 minus 2, it's going to be 0. So in place of this, I'm going to write it as 0. That is the meaning of operations, elementary operations. There are two operations I can perform, either row wise or column wise. So I'm explaining the problem from row wise. Right, okay. So my intention was, this element was required 1, it is already 1, so nothing to change. This element should be made 0 and it is 2. To make it as 0, I will just see above that what is there. Above that there is an element 1, and if I multiply 2 to this and if I subtract with this element will be going to be 0. Not just for this one element. Look here. These 4 elements, okay? 1, 2, 3, 4. All the 4 elements. I have to apply the same operation. So I've done it for one element, so let me continue. For this also I should apply the same. Yeah, right. Now this is an element of R2, so 3 minus 2 times above this there is an element minus 1. So on solving, this element will become 5. So in place of 3 I should write it as 5. R2 minus 2 times R1. So that element is going to be 5. Come here now. Write down the first row as it is 1 0. Now look second now. These two elements should be operated using the same operation what I have written here. R2, this is an element of R2, 0 minus 2 times above this there is an element 1, that is minus 2. So in place of this minus 2. So I suggest you till you get used to this, write down separately and do it. Okay. This is also 1 minus 2 times 0. R2 minus 2 times R1. So what happens to this now? This is going to be 1. Write down this matrix as it is. Clear students? So I wanted 1, I have 1, so I didn't do anything for this one. Below this, the elements is actually, below this the element is 2. I want to make it as 0. So let us concentrate on making this element. See, what happens to other elements, let us not worry. What happens to this element, that is required, that is more important for us. So this element has to be made 0. So simply you multiply the same element to the element above that and subtract it. It's just so simple, right? Then the next one, come here. I got these two, 1 and 0. This is also 1 and 0. I got it. The next thing, this element should be made as 1. See, operation should be performed in anti-clockwise direction. This is the direction which has to be followed. So check one by one. So first, this should be made 1. This should be made 0. This should be made 1. This should be made 0. See the operation. Anti-clockwise direction I am going to follow. If it's row wise, if it's column wise, then clockwise direction should be. It's not that it cannot be done in column wise. It can be done in column wise also. A little changes. Clear? Right. Okay. Now come back here. Now my next thing is, after making these two elements as 1 and 0, which is same like this, I am going to concentrate on this one. That means this element should be made as 1. What is the element I have here? 5. So whenever you are performing some operation, no, you round off those elements. That will gives you a hint what to do. Right. So this element should be made as 1. How can I make it 1? If I multiply this element by the same, that means 5 multiplied by 1 by 5. The element is going to be 1. Again, that's an element of R2 only. Right. So R2 elements will be written as 1 by 5 times R2. That means each element of R2, all this 4, each element of R2 will be multiplied by 1 by 5. So R1 no change, 1 minus 1. So 0. 0 by 5 will be 0. Next, 5 by 5 will be 1. Then 1, 0. These two elements are also multiplied by 1 by 5. Multiplied by 8. I'm almost close now. Okay. So I required 1, 0, 1. I got 1, 0, 1. 3 elements are done. What is my next thing? I should concentrate on this. What is that I should make this element? I should make this element as 0. Right? And this time, this is an element of R1. You want to make it as 0? This is already minus 1. Add with this. The element is going to be 0. So a simple operation, R1 will be written as R1 plus R2. But not just for 1. All these 4 elements will carry the same operation. Correct now? So 1 plus 0, 1. Minus 1 plus 1, 0. R2 will be written as it is without any change. Come to the right side. 1 minus of C, we are adding actually. So it's actually what? 1 plus minus 1 by 5. So on taking LCM and simplifying, this is going to be 4 by 5. That's okay? Right. That's fine. Sorry, 5. This is 2 by 5, right? Sorry. So that's going to be how much? 5 minus 2. That's going to be 3. That's okay now? Fine. Now the next thing, 0 plus 1 by 5. 0 plus 1 by 5 is going to be 1 by 5. So this is minus 2 by 5 and 1 by 5 multiplied by 8. Did I get my required matrix? Yes. Now the left side was a matrix A I started. Finally, I ended up making the left hand side as an identity matrix. Okay. And right side, it was I. It is converted to some other matrix here. So finally, what I got here is A inverse equal to 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. That is the inverse of the matrix. First problem, students, so not to worry. Okay, just another few problems you will get to know exactly what is the meaning of elementary transformation. We are transferring some elements. We are using some operations on the elements actually. Okay, that's the meaning of elementary transformation. Don't go in deep actually. Apart from this, in determinants you will study this how actually this should be done and why this changes has to be done. That you will take up later on while doing determinants. So right now this is the procedure. So start from A equal to I into A. So write down A equal to I into A. So the concentration should be on the left hand side. See, something whenever you do something here, no, the same changes apply to this matrix also. So let us not worry about this thing. You concentrate on only the left hand side. So finally left hand side matrix has to be reduced to an identity matrix, right, by using some elementary transformation. At the same time, this matrix will be converted to some other matrix. So whatever the matrix is next to A, this matrix is nothing but the inverse of the matrix. That's how it should be done. A simple concept. So let's move on to the second problem is A is equal to 2, 1, 1, 1. So the procedure says let A is equal to I multiplied by A, 2, 1, 1, 1. Correct now? Is equal to I 1, 0, 0, 1 multiplied by A. What was my intention? The left hand side should be converted to identity. So I know this should be converted to 1, 0, 0, 1. But what is my first element here? 2. That should be made as 1. See, this is how the elements operate. Will be changed actually. We are going to take one element at a time, not every element, not all the elements. Clear? So if this has to be made as 1, there are two options. Either that's an element of R1, right? What I will do, 1 by 2 multiplied by R1. 2 by 2 is 1. That's one method. Otherwise, what if I subtract these two? So I can go for R1 as, see, it says R1 as R1 minus R2. 2 minus 1. So it's going to be 1. So any of the two operations are fine. So I'm going to go with subtraction, which looks easier for me. So R1 is written as R1 minus R2. So 2 minus 1, 1. 1 minus 1, 0. No changes in R2. Remember, R2 is still the same. And here also you have to apply the same operation, right? 1 minus 0, 1. 0 minus 1, minus 1. And no changes in R2 as it is. So my required element was 1. I got it 1. My first step is clear. I got this thing. Now my second thing is this. What is the element? See, I'm just trying to highlight the elements whenever I do some operations. So it shows actually what that element has to be done. You also practice the same way. This is 1, but that should be made as 0. And that's an element of R2. If I, sir, so you will be asking, sir, if I subtract this also, I'm going to get 0. Fine. Then when I'm doing this, we're actually taking column wise. But I started row wise. I should continue row wise. Clear? So what I can do here, I can subtract these two and it becomes 0. So R2 element will be written as R2 minus R1. So no change in R1 then. So it should be 1, 0. No change in R1. 1 minus 1, 0. 1 minus 0, 1. Clear. And here, come back to this now. So no change in first row, 1 minus 1. Subtraction, right? So it should be 0 minus 1, minus 1. 1 minus of minus 1, 2 multiplied by 8. Look at that. I didn't even go for my last element. Okay, I just did operations only for these two. Automatically, these two elements are the elements which are required. Correct now? See, I did only two operations actually. One is this and one more is for these. Correct now? While doing this, automatically these two elements are already 1 and 0, which is same as what I required. So there's nothing else to continue, right? So what I got here, that is nothing but my A inverse. A inverse equal to 1 minus 1 minus 1, 2. This is how it should be done. Clear? So it's not that 4 times I should do operations and then I get it. No. Sometimes 1 or 2 operations only will get the required elements. So what is the beginning? What is the end? That is most important. How to start? How to end it. Clear? So that's problem number 2. So let me start with problem number 3. 1, 3, 2, 7. Problem number 3. A is equal to 1, 3, 2, 7. So let's start finding the inverse. So the step says let A is equal to I multiplied by A, 1, 3, 2, 7. 1, 0, 0, 1 multiplied by A. See students, you can understand this. See, if you wish, this can be one of the easiest topic. Or if you don't wish to learn this topic, this is going to be one of the toughest topic. And most of the students will quit, maybe lack of proper guidance, okay, or lack of practice, or lack of interest, because of these 3 reasons. But actually there's nothing to lose. Okay, so this procedure is quite simple. We can make it. So what I want, the left hand side should be converted to 1, 0, 0. And that is the hint which you have to start in your mind first thing whenever you see the problem. So I wanted 1, it's already 1, nothing to do. I want 0, here it is 2, and that's an element of R2. Correct now? Fine. So what I will do here, if I multiply 2 and subtract with this, you should not write it as 2R1 minus R2. You should not write it. You're starting for R2, you have to start from R2 only. This is not allowed, remember. Then also it's going to be 0, but the formation is not allowed. R2 minus 2 times R1. So no change in R1. 2 minus 2. If you're finding it difficult, please write down no sign and practice. R2. What is the element in R2? Element in R2 is 2. Minus 2 multiplied by R1. Surely it's going to be 0. Now the next thing, this is 7 minus 2 times just above this 3. That's an element of R1. That's going to be 1. That's okay. Perform the same operations here. No change for R1. 1, 0. Now here it should be changed. 0, 0 minus 2 times R1. That's minus 2. So here that's going to be minus 2. Correct now? The next thing. 1 minus 2 times. Right. 1 minus 2 times 0. That's going to be 1. That's fine. Right. I wanted 1. Okay, got it. I want this as 0. I made it. I want this as 1. It's already 1. So nothing to do. Nothing to do anything for this element. Now your aim is this. Okay, now this is an element of R1. This should be made as 0. R1 can be written as R1 minus 3 times R2. R1 itself you have to start. You cannot say R2 minus. Answer is going to 0 is going, you will going to get it. But that formation is not allowed. Okay, now the next. Let us start with R1. 1 minus 3 times 0. 1 minus 3 times 0. It's going to be 1. Next is 3. 3 minus 3 times 1, it's going to be 0. No change in R2 as it is. And on the right side, 1 minus 3, see 1 minus 3 multiplied by minus 2, and that's going to be 7. Next, right, 0 minus 3 times 1, and that's minus 3. That's R1. R2 elements minus 2, 1. That's okay, right. Multiplied by A. I got an identity matrix in the left side. So the matrix what I got it here is nothing but inverse of the matrix 7 minus 3 minus 2 and 1. Fine students, let's move on to the next. This is actually the last topic of this chapter, so I will explain most of the problems. Okay, in the exercise there are 14, at least some 10 problems I said. I know why sir so many problems we can work out. I know people can work out. Okay, but still I will just try to do as many problems as possible. So under this problem number 4, matrix A is given as 2, 3, 5, 7. That's fine. Okay, what happens? Let's see. So let us start the procedure. Let A is equal to I multiplied by, you have to write this, right? Then 2, 3, 5, 7 is equal to 1, 0, 0, 1 multiplied by A. What was your aim? You have to make this element as 1. So simply I am going to go for this element as R1 as 1 by 2 times R1. Each element will be divided by 2. So this is going to be 1, 3 by 2, 5, 7. So here also you have to perform 1 by 2, 0, 0, 1. This is R1, that is the meaning. Clear? The next thing. This is 1, and now I will concentrate on this element. Okay, first element I will concentrate. Now this element has to be made 0, and that is an element of R2. Correct? Now that's an element of R2. R2 is written as R2 minus 5 times R1. R2 minus 5 times R1. So no change in R1. 1, 3 by 2 as it is. 5 minus 5, 0. I know you will find it difficult now, so write sideways somewhere. So it's going to be 7 minus 5 times 3 by 2. Take LCM and simplify now. So 14 minus 15, that's minus 1. So this is going to be minus 1 by 2. Now the next 1 by 2, 0. No change at all. Now change these two elements according to the operation what I have written here. Okay, here. So 0 minus 5 times 1 by 2. So that's going to be minus 5 by 2. Right. The next. Of course, this element is going to be just 1. If you want, you can just check. What's my next thing? This one. What should be that? That should be 1. So multiply R1 minus, multiply each element of R2. That's an element of R2. Multiply each element of R2 by minus 2. That's enough. So on doing this, 1, 3 by 2, 0. Right? 0 multiplied by minus 2 will be 0 itself. Then if I multiply minus 2 for this becomes 1. And here 1 by 2, 0. On multiplying minus 2 for this, I am going to get it as 5, and this element is going to be minus 2. The last thing, make this as 0. So this has to be 0. That's an element of R1. R1 is written as R1. You multiply the same element to this and subtract. That's okay? Right. So on doing this operation, the left hand side remains the same. 1, 3 by 2, 0, 1. Fine. Now let's come to the right side. What's the operation says? R1. Now what is the element of R1? 1 by 2, right? Minus 3 by 2, 1 by 2 multiplied by 3 by 2 times R1, right? 3 by 2 multiplied by 5. That's okay. So let's take the LCM for these two. So I'm taking LCM. So 1 minus 15. That's going to be minus 14, or it's going to be minus 7. That's okay now. So this element will become what? Minus 7. Now perform the same operation. See, all these elements has to be done with the same operation, right? Okay. Now here it's done. Now let's concentrate on making this. Sorry, I didn't do here. This actually becomes 0. So let's concentrate on here. 0 minus. See, R1 is 0 minus 3 by 2 times R2. Element of R2 is minus 2, or it's just going to be 2 you can cancel. The remaining is just going to be 3. So this will become 3. That's fine. Now what is next? R2 elements 5 minus 2 as it is multiplied by A. Is that clear, students? And that's how inverse has to be performed. Okay, so you can notice the left hand side was matrix A in the beginning. Now there is an identity matrix. So this matrix is nothing but inverse of the given matrix, minus 7, 3, 5, minus 2. After that finding inverse in the determinants, I will let you know how to cross verify whether what we got it is correct. Because in that method it's easy to find out inverse. It's hardly in 1 or 2 steps I can just find out the inverse. That's very easy. So in determinants, after studying in determinants, I will tell you how to cross check whatever we got it is correct or wrong. So we have to wait till then for verification method. Hope it's fine, students. So 4 is over. So I'm going to start with 5. A is equal to 2174. 2174. Student, this time I want to do column wise operations. I just want to give a try. Okay, and I want to even learn, even it's possible to do with column wise operations also. So beginning, let A is equal to, when you start with column wise, A into I, that is what we have to write. That's one thing, first thing changes. So here it is 2 1 7 4 is equal to A as it is 1 0 0 1. I said column wise. So when it was row wise, I should used to go anti-clockwise direction, correct? Now go in this way, go clockwise. That means I'm going to start from where? I'm going to start from this element only. First thing is this element only. That should be made as 1, right? Because that's what my final intention. This should be converted to identity matrix. What you can do simply here, this is C1, this is C2. If I'm writing this symbol, look at that, I'm writing arrows on both. This shows you are interchanging first and second column. I interchange the first and the second column. And here also A as it is 0 1 1 0. Interchange first and second column, first thing. So I required my 1 and I got it 1. Now don't start it now. If you are starting this, this becomes a row wise operation. After this you concentrate on this element. This should be made as 0. So this is an element of C2. C2 will be written as C2 minus 2 times C1. C2 will be written as C2 minus 2 times C1. Fine. What is C1? 1 4. No change. 2 minus 2. Because you are performing this operation, right? 2 minus 2 into 1. So it's going to be 0. And what is the next one? The next one you have to perform the same. For 7 also you have to do the same operation, right? 7 minus 2 into 4. So that's going to be minus 1. Close it. A as it is. Come back here. 0, 1. Write down as it is. Now look here. This is 1 and 0. I should apply this operation. I should apply this operation. This is an element. These are the elements of C2, right? So this one will become 1 minus, that is C2 minus 2 times C1. C1 is 0. So it's still going to be 1 only. And if I do it for the next one, 0 minus 2 times 1. C2 minus 2 times C1. So it's going to be minus 2. Fine. So 1 0. The next target should be this. That's an element of C2. So C2 will be written as C2 multiplied by minus 1. Each element of C2 will be multiplied by minus 1. So 1 4 0 1. These two should be multiplied by the minus 1. And here A, this is 0 1 minus 1 plus 2. That's okay now. So we got, see, 1 0 1. We got till here. The last target should be 4. Right. Now that's an element of C1 this time. So C1 will be written as C1. You have to make this one as 0, right? So C1 minus 4 times C2. If I multiply 4 here and subtract, the element is going to be 0. So it should be, for operation should be performed for these two elements here. So 1 minus 4 multiplied by 0 is going to be 1. So here 4 minus 4 will be. So let's try now. Few more. That's fifth one. Not to worry. Okay. If you are finding row-wise operations actually easy, and you can remember actually, right? So if you think that I am comfortable in row-wise, please continue. Nobody will ask you what method you have applied, whether row-wise or column-wise. They are just worried about the final answer. So you perform one method, you stick on to one method, not an issue. Right. The next one. So problem number 6. A is equal to 2 5 1 3. Okay. So 2 5 1 3. So let me start with, let A is equal to I multiplied by A. So 2 5 1 3 is equal to 1 0 0 1 multiplied by A. So what was my intention? Right. This has to be made as 1. Correct? Now I am going to start with the row wise operation. So I have to go anti-clockwise direction. So this is an element of R1 and this is an element of R2. I can interchange R1, R2. That is one method. Otherwise, R1 will be written as 1 by 2 times R1. Any of these two operations you can apply. Interchanging is actually easy. So let me interchange 1, 3, 2, 5. So here also 0, 1, 1, 0 multiplied by A. So I wanted 1, I got it, right? So my first intention was this. Now this has to be made as 0. And that is an element of R2. R2 minus 2 times R1. See, why I made this one, I want an identity matrix. This has to be made 0 because of my identity matrix. So if I want to make it as 0, multiply the same number to just the number about to that and subtract with the same. That's the operation. So if I operate that, first row no change, 1, 3, 2 minus 2, 0, 5 minus 6, that's minus 1. And here, first row no change, 0, 1, 1 minus 2 multiplied by 0, that's 1, 0 multiplied by minus 1, that's minus 2 multiplied by 8. Okay, what was your next thing? This. What is that should be made as? That should be made as plus 1. So, R2 is multiplied by minus 1, that's enough. Correct no? So, 1, 3, 0, 1 equal to 0, 1, minus 1, 2 multiplied by 8. 1, 0, 1. The last target is this. That should be made as 0. That's an element of R1. Correct now? So, R1 is written as R1 minus 3 times R2. R1 minus 3 times R2. So, 1 minus 3 times 0, 1, 3 minus 3, 0 and no change in these two. Here also, when you do the operation, I suggest you to write on the side by corner and practice this. Element of R1, 0. Minus 3 times minus 1. So, this is going to be plus 3. Next, element of R1 is 1. Minus 3 times R2, R2 element is 2. 1 minus 6. If you write side by and practice, there are less chances of any errors. So, write, practice and then learn. Okay. So, let me write down the remaining. Minus 1, 2 multiplied by A. So, the left side is an identity matrix. So, whatever the matrix I got it here, that is nothing but the inverse of this matrix. Therefore, A inverse equal to 3 minus 5 minus 1, 2. I know some of you are already getting confused and you are telling that no, I will quit this method. No, don't leave it. Don't quit till you practice. Okay, after you practice and after if there are any doubts and after you ask for us clarification, if still you think that you cannot learn, then quit. Okay, but don't quit before practicing the things. Okay, so let's move to the next one. Students, I know enough number of problems are already done. I just wanted to concentrate on the last problem. One last problem and I will stop it. The last one, that's 14. Why this problem I am selecting, I will tell you later. This one particular problem, it's a bit interesting. Procedure remains the same. Let A is equal to I multiplied by A. Okay, 2, 1, 4, 2 is equal to 1, 0, 0, 1 multiplied by A. What is my target? This has to be made as 1. So R1 is R1 by 2. That's enough, no? So 1, 1 by 2, 4, 2. No change. Correct. So 1 by 2. Here also. These are also elements of R1, right? 0, 0, 1. Right. My next thing is this has to be made as 0. That's an element of R2. Correct, no? Okay. So R2 is written as R2 minus 4 times R1. Whatever the number is there, multiply just above that and subtract with the same. So on doing this, first row no change, 1, 1 by 2. Correct, right? So 4 minus 4, 0. Right. And see what happens next one. How I got 0 is R2 first element is 4. So 4 minus 4, just above that 1. So it's going to be 0. The same thing should be applied for this also. 2 minus 4. Just above that I have an element 1 by 2. What is that I am going to get? I am going to get this as 0. Okay. The right side have some matrix. So on the right side have a matrix called as 1 by 2, 0. Right. So 0 minus 4. So that's going to be minus 2. Then it's going to be 1. Students, let's take a look. What was my target? My target was this left hand side matrix should be converted to 1 0 0 1. This was my target, right? Okay. I wanted my first element as 1. It was not 1, so I made it 1. First thing is clear. So below that I wanted 0. So when I was trying, I got 0 also. What's my next thing? This element has to be made as 1. If it is a 0, how can I make it as 1? That's impossible. Clear? And in the beginning, you have to understand the statement heading. Find the inverse if it exists. That means for every square matrix, you cannot find inverse. Or inverse of every square matrix does not exist. Clear, students? Inverse will exist for only certain matrix, not for every square matrix. Right? It's not that for every matrix there should exist inverse. Oh, I'm getting 0. That means I've done something wrong. Nothing wrong. Everything is fine. Inverse of every matrix does not exist. That is the statement what you have to remember. So how to conclude it? I wanted 1 0 1 0, correct now? But look at here. This element is already 0. That means in one row all the elements are 0. Then therefore A inverse does not exist. That is the reason why I selected this one. So you cannot find out inverse of every matrix, right? So when doing operations like this, if one row or one column will become completely 0, in such case stop and give a conclusion. Okay, since the elements of R2 are zeros, therefore you cannot find the inverse, or you can just say A inverse does not exist. Right, students, this is the only one problem of such kind in this topic. Okay, so you cannot find out inverse of every problem. So I almost explained you 7 problems. The other 7 you can do it. The only thing is how to perform the operation. That's it. That you have to remember. So you have to just remember how to start, how to end the elementary transformation problem. So the beginning is A equal to I into A. I want you to stick on to row operations only. Okay, you stick on to one method. There is no problem at all. Fine. Okay, and you know what to do actually, how to do the operations in anti-clockwise direction. So first make it as 1, make it as 0, and make it after doing 0, make it as 1, and then make it as 0. In that way you have to remember the order. Yeah, when doing all these operations, whatever the operations you apply for the left side, the same thing apply even for the right side. So keep simplifying till this becomes an identity matrix. Then whatever the matrix is here, that will be called as inverse of the matrix here. 0, and this will be 0 and 1. A as it is. Now perform the operation here now. So if I perform the operation for C1 here, so 0 minus 4 times minus 1. C1 multiplied by minus 4 C2, right? So on simplifying, the element is going to be 4. Do the same thing for this one now. 1 minus 4 times 2. 1 minus 4 times C2. That's going to be minus 7. That's okay? And here it is minus 1 and right. Yeah, that's absolutely fine. Okay, I will tell you the verification method later on. I will teach you that later on. Okay, so not to worry. This is one problem I am telling you. You can perform even column wise operations also, and you will still get the same answer. Fine, students. So we ended the chapter of matrices. Simple chapter, not too many problems, not too many topics. Miscellaneous not required right now. So let's see later on stages, if we required we will do it. So let us stop this chapter. It's over. That's the end of the chapter matrices. So any doubts or clarification, please call to us. The last thing, please work out the home exercise problems to make it better. Okay, thank you.